So I'm just going to cover some of the aspects of drilling for mine water heating and cooling. Based on quite a number of years' experience, I'm a mine surveyor by background, so early parts of my career was spent surveying mines underground, then went on to the Coal Authority, heading up all the mine water programme from inception in 1994 to 2011. Then spent quite a bit of time on abandoned mine methane, drilling into coal workings to get gas out for a good number of years, and then back to the passion, which is mine water heat. So just a brief overview. I'm just going to touch on some of the high-level principles, a little bit about mine surveying and mine plans and how that developed, a couple of simple case studies, a little bit about risk and mitigation, and then just a light background about some of the things that have gone well and some of the things that have maybe not gone so well, but have got there in the end, and observations. Within the time available, there can be lots of aspects to drilling. This is only a very narrow view on really the underground mining and the plans. I'm not going to cover geological matters or anything like that, or anything to do with mine gas precautions. So assessing the mine workings, I think as David Burks pointed out earlier, you do need a good connection, hydraulic connection with flooded workings. You need to get a good yield to feed the heat scheme, and we tend to use a rule of thumb of about 50 litres per second per megawatt. And also, as David pointed out, you need a proven underground flow path between re-injection and abstraction. So in effect, you've got your rechargeable thermal battery. But also you need to try and maximize the underground flow path between re-injection and abstraction, again, to maximize the chance for thermal recharge as mine water goes through the workings. So some of the things that influence the assessment is the age and quality of the mine plans, the type, age and extent of workings, which will give you confidence or lack of confidence about hitting target and how much yield you're going to get. The geometry of the workings, so multiple pathways into your boreholes are good because there's always a chance of collapses underground and restrictions. So the more pathways you've got, the better. A multiple seam working is not absolutely essential, but a big advantage in that it can maximize the flow path between your boreholes. And sometimes you can get sort of pathways of several kilometers underground, even though the surface position of the boreholes might be within, say, 10 meters. And also the depth. Deeper means more expensive drilling, but also the waters down there is much warmer. So a little bit about mine surveying and mine plans. I mean, coal mining's taken place as long ago as the 13th century. Lots of unrecorded workings out there, and really techniques around surveying mines didn't start until 1556 with the publication of De Re Metallica. And the little picture on the right hand side there shows one of the diagrams from the book about the early attempts at sort of plumbing down mine shafts to convey sort of surface correlation to underground. But it wasn't until 1875 that was actually a legal requirement to deposit mine plans. And even from that day, when plans were deposited, often they weren't complete, or you can find that there are plans that contain conflicting information, and so on. So you really need to be cautious and understand the nature of what you're dealing with. And then over the years, surveying has developed well on from the diagram you see on the right. And the real step forward was when the coal industry was nationalised in 1947, that the National Coal Board actually brought in a code of surveying practice which standardised the way in which all mines in Great Britain were surveyed. So just a very quick one about, looking about how things have developed. Well, originally magnetic compasses were used and Gunter's chains, as it's called, to survey the mines. Before that, probably even more rudimentary measures. And then as mining dials, steel tapes developed, and then more recently gyrotheodolites, where you could get bearings underground, azimuths underground to very accurate degrees of precision, and electronic distance measurers, again, that you can measure long distances very, very accurately. So surveying did develop, and georeferencing of plans and availability of surface features is one aspect of it, but just how well things are done underground is another one that you just need to be aware of. So mining techniques have developed over the years. The very, very old workings were often what we call board and pillar. We've seen one or two slides in earlier presentations about what they look like. This is another iteration, but often they're very old. The workings are quite poor, but also even looking at the records, pillars can have been robbed, coal taken out, and there are different representations of them. As you go on through time, things moved on to longwall working, where you've got roadways, access roadways, and you've got collapsed strata between where the mined out coal had allowed this overlying strata to collapse into it. You can get a better yield if you can hit a roadway, because obviously you've got a better flow path through. The Gulf is almost like a sponge. You can get water out, but it's probably that you're going to get a significantly lower yield from that. Then if you go on to the more modern things, that's just a picture underground of a relatively modern roadway junction, but you can see there from the plan is much better, and you can use these plans to get quite accurate locations underground, and you can form a view on, if it's not been worked around in a longwall way, that you're likely to get a roadway that stands in better condition. Lots of survey information available. Again, it's been touched on a few times about information that's available at the Coal Authority. There is the Mining Heritage Centre, which has got over 100,000 deposited mine plans of all different types, from very, very ancient roll plans to quite modern flat sheets on metal, paperback metal, 2x1 sheets. What is often useful is that, as well as the plan, there may be survey records that are held there. And you can see there some of the notebooks relating to one project they're working on at the moment. Surveyors' notebooks from when the surveys were actually done underground, but also coordinate ledgers, which contain the accurate coordinates of survey stations underground, abandonment reports, which cover connections to other collieries, and borehole and shaft records. But you know, that's one source of information. Local archives can often hold lots of other pieces of invaluable information. And never forget that there are still people around that used to work at some of these mines from British Coal who've actually been underground and can provide a valuable input. But you do need to be careful, because even though you come across what looks to be quite a modern plan, it may be that some of the old workings have actually been traced from a very, very old plan. So you might kid yourself and think you've got an accurate plan, but the plan or the workings are only as accurate as the original source. Just a couple of case studies. Charlotte and Dan sort of went through this yesterday about Gateshead. This was one where very, very old pillar and store workings. On this plan from the higher seam, the high main, there's actually suspicions that it had been worked in that area up to outcrop, but actually no recordings. With little confidence about the accuracy of those plans, and probably plus or minus 10 meters is as good as it gets. Working depth 50 to 100 meters. That ended up needing quite a number of boreholes to actually get successful connections with sufficient yields. And the approach partway through had to be adopted to do actually probe holes, where you could put quite quick, quite cheap holes down, get to hopefully a target underground. When you did get a void, you got water, you can survey that, and then you can actually lay out your position for your final production holes. But in that case, it ended up within 13 boreholes being drilled to get 5 really sufficient for going into the production scheme. So it did take a significant amount of contingency, but the scheme is now fully operational at 6 megawatts, and we'll watch that with interest, particularly with the living lab now going in that area to see what's happening underground. Another one, this was actually coal mine methane experience, but it's still, you know, hitting targets underground. This was at Clipston in Nottinghamshire, targeting a junction underground. Because of land availability on the surface, and also because of the presence of old workings, which we prefer not to drill through, the hole was actually steered to go around to hit the roadway, which was 840 meters deep, which, you know, is very, very similar to the one that was being talked about yesterday at Bockham. But the features here, relatively modern workings. You can see the dates, 1950s. Scary that I think of that as relatively modern, but in mine surveying terms it is. And you can be confident of the target to better than a metre. You see these crossed with the numbers. They're survey stations. You can actually get the coordinate ledgers from mining records, and you can get that position within a very tight precision. So that's successfully connected to the workings. Unfortunately, we were looking for gas, but they turned out to be flooded, and the water came up the hole to 750 meters from surface. But it's just one example that you can actually, in the right circumstances, with the right records, the right workings, you can be confident of hitting at depth. So just expanding a little bit more on confidence on target. The sort of chart on the left there is just a sort of examination of 30 successful drills, which were done for various things, mainly for coal mine methane, but they were depths up to 840 meters, but there were lots to fairly significant depths. 13 of those holes were steered. Some of them a lateral displacement of up to 370 meters, but the feature there was relatively modern roadways, relatively modern plans, and every one of those hit target successfully. In addition to those, the coal authorities drilled over 140 boreholes into mine workings, again all successful, which are used for monitoring water, not for pumping. I've said struggles rather than failures. It's not a failure, just moved on to Gateshead again, as I've described. That was more of a struggle, took longer and had to have more boreholes, but it shows that if you adopt your approach and you persist, then you can get there in the end. So just to sum up some observations, I know Dave Burks mentioned earlier about a 50% contingency overspend being the norm. You know, my firm view is that there is no average hit or miss rate. Every case has got to be assessed on its own merits, based on the records and other factors which I've not considered today to feed in. So it can be that you can get away with quite a small contingency, or you might need something that's, you know, 2 or 3 times your original budget. Often the deeper workings have got better records because they are newer workings. Like for like boreholes at depth are more expensive. But the need or the likelihood of needing multiple drills is less, but you do get significant higher temperatures, which will give better COP. And pilot holes proved invaluable at Gateshead in just more cheaply trying to get on top of where things are. And directional drilling, it's done at Clipston, it's been done at a number of the coal mine methane ones, it's been done at Bockham, and that is a good technique. So, you know, parting shot is, I think the detailed interpretation of the source mine plan by appropriately experienced personnel is absolutely key to all this. You know, there's no guarantee in any of this, but I think you can give yourself a better chance by understanding what's down there. So that concludes what I've got to say. So thank you very much for listening.